All right. So the first few pages of this chapter are going to just go over how these systems are set up. It's not that important. The most important part of this chapter is an intro to relational databases and how to use SQL. And I am going to give you examples of both. All right. When we're going over this stuff, if there's something that's in here that doesn't make sense, I'm just going to take for granted you're going to ask. All right. I will tell you that if it was up to me, I don't know how we'd work it into the curriculum, but if it was up to me, we'd have a whole class on databases because, well, for two reasons. Number one, for lack of better words, they can be really fun. If what we're going to start doing may not seem fun, but when you start to think of the ramifications and how powerful it is, it becomes, more fun, for lack of better words. The other thing is, no one would leave a 2-year college, even if you took a class in it. Let's say we had a database program. We don't, but let's just say we did. Even if you took 4 classes in databases, you wouldn't leave this college and probably become a database administrator at a company. All right. You would be able to work with databases, but a database administrator, they've done studies and stuff, and around the country, those people average making between $150,000 and $200,000 each. They're in charge of the data for the entire company. What does that mean? Well, what it means is the most important part of a company is its data. And if you don't agree, think about this for a minute. Think about what would happen if it was the beginning of the semester. And let's just pretend for a second that we have, 500 people at our campus between day and night, whatever. And let's assume that out of those 500, 250 have paid, 250 have not yet paid. Now there's some kind of a catastrophic thing happens, and all of the records for every single student have been wiped out of our database, and they're not retrievable. Now the school has no idea who's paid and who hasn't paid. All right. So what I'm telling you is data is the most important part of any company. That may not sound fair. And I gave this speech once, and one of the students raised their hands and said, "You know what? I work at whatever." And they said, I'm one of the most important parts of the company. And I said, "Okay, this is how I do a litmus test on this. Let's assume that you left here today and you got into a car accident. You were either killed or you were so incapacitated that you couldn't work for quite a while. Would the business still be able to go on?" And the person said, "Yes." I said, "Then bottom line is you're really not that important." And I said, if I'm hurting your feelings, I'm not trying to. But it's just like me. Angie, you've heard this probably, but you weren't here. Keegan was. No, in fact, neither one of you were here. Last March, when I had a medical situation, and Evan came over for a week. And he took over. In fact, it was the C# class that he took over. All right. And if it had been longer, they were already coming up with contingency plans. So the bottom line is the data is the most important part of any company. And I shouldn't have to say any more to try to convince you of that. So what we'll do first is we'll talk about the hardware parts, then about the software parts. All right. So let's go ahead and do that. All right. Client server, believe it or not, is kind of an older term. It's not out of vogue yet, but this is what I want to show you. All right. Do you both understand? You have all heard the term the cloud, correct?
Yeah.
And I don't know how you define the cloud. All right. But to me, more than anything else, the cloud is the internet. All right. So when you say we're saving something off to the cloud, you've got some kind of if it's actually being saved, it has to be saved somewhere. All right. But if you look at this situation here, these clients, they're all made to kind of look like they're probably desktop or laptop computers. And you're both smart enough to know today there's desktop, there's laptop, but there's also phones, there's also tablets. There's people who walk around with different types of devices. But the bottom line is this: the clients need information. When they need information, they either directly, if they know database, write database queries, or they've got some kind of a program that someone has written for them that allows them to make queries. It might even be voice activated. Someone from here might be able to just go and have a program where they talk into their computer and say, all right, can you tell me which product between these 5 products, which one had the greatest sales in 2019? They bring in that information. Typically, that information is going to be stored in a database someplace. So it goes into the cloud, and the cloud calls and sends that information to a database server. That database server looks up the information, sends that information back to the cloud, that sends the information back to the client. All right. Now, I don't know if either one of you, and I don't have one, but I don't know if either one of you has an Alexa or an Echo or any of those things. But when you think about it, that's kind of the way it works. You know what I'm talking about?
Yeah.
Okay. Now, in a big company, there could be hundreds or thousands of these servers. And when you think about it, with a company of any size, probably you're going to have more than one database server. In an ideal world, you'd have a few of them, and you could partition the work off between, let's say we had 5 of them. They could each be doing 20% of the work. Now, if one goes down, then the other 4 have to pick up 5% more work, and you can do the math. But the other thing too is, I mean, not all coronavirus, etc. aside, if you're going to have database servers, they're probably not going to be all in the same building. They may not even all be in the same country. All right. I mean, think about it. You know, when you think about floods and hurricanes and stuff, if you have 10 servers and they're all in the same building and you get a hurricane, they could all be ruined. All right. So the way this is typically set up is you create what's called a database server farm. All right. Where you have multiples. All right. So as it says, the clients are the PCs, but they're more than that. They're the PCs, they're the phones, the tablets, etc. The server is a computer that stores the information the client needs. There's nothing special. In the olden days, these were real big machines. And for some companies, they still are. But for other companies, they may look like your machine or my machine. But inside, where we might have 4 gig or we may have 8 gig of RAM, all right, they may be configured to have at least, at a minimum, maybe 256 gig of RAM. And instead of having maybe a gig hard drive, all right, they may have 100 gig hard drive, etc. All right, so the network, it says, consists of the cabling, the communication lines, and the other components. That's not said well. And what I mean is, most of the time, there's no direct connection between any of this. Technically, I guess you're connected directly to the internet, but you're not connected directly to any database server. All right. This even works this way, just so you know, you probably have already figured it out. If you go to rankin.edu, they've got a database server. All right. If you go in there and you go into Inside Rankin and you ask them, for example, for a copy of your transcripts, that's got to do the same way. You, through the network, do a database server. Back to the network, back to you, type of an idea. All right. So with a client server system, as it says, the server is typically a high-powered PC. And it can communicate over a local area network. But a local area network implies that what you have is a connection of some type. So more often than not, you're going to be connected over a wide area network. Now, if you remember back in the old days when we had a classroom, you saw those machines that were already in the classroom, the ones that we don't use. Well, those machines literally are all hooked up in a local area network, and they're used by the hardware program. All right. What we're doing now is we're working over a wide area network. Okay. That's the hardware components. So what about the other side, the software components? I don't know if I ever mentioned this to either one of you or not. Mr. Corrigan and I, we were talking, believe it or not, tomorrow at Rankin was supposed to be our Rankin-Wentzville open house. And that usually is when we get the most people, that come in that end up signing up for full. The point is we when we had our open house in fall, not the spring one, but in fall, Mr. Corrigan and I were talking. We were talking about the differences between our programs. And I said, in my opinion, to keep it real simple, okay, if you look at a human being, if you just break it down, I know a human being is bones and all that, skin and all that, I don't care. But a human being is a body and a human being is a mind. I said, what they teach in the hardware program is the body. What I teach in this program is the mind. And you have all known people, especially as they get older, sometimes their body is still okay, but their mind goes. And other people, their mind is still good, but their body goes. And when I explained it to him in that way, he kind of laughed. He said, I never really thought of it that way. I see what you're saying. He said, I'm not saying I totally agree, but I see what you're saying. Well, the reason I'm telling you that is the database management system, the DBMS, that's the mind of the database. All right. We're going to end up using, starting next week, Microsoft SQL Server. All right. If it does turn out, and I don't think it will, that you don't have it on your machines, I'll show you how you'll be able to go in and load it all. But you shouldn't have to. I believe with the install that we did, all the stuff that we need will be there. We'll know real fast. It's not that big a thing. But it says the DBMS manages the database, the databases that are stored on the server. In a little bit, I'm going to literally just bring up an editor on the screen, and I'm going to start giving you some stuff. You don't have to write it down, but I'm going to give you some definitions and some terminology, etc. And we're going to talk about it. All right. So it says each client machine, so you, requires application software to do useful work. Well, the application software you've been using for this entire course has been C#. What we're going to start using in conjunction with C# is the Microsoft SQL Server database management system. All right. Now they go through this stuff, and is it important that you understand it? No. But the point is, there has to be a connection between the database and the software that's using the database. All right. And it says to allow this communication, we're going to use something called ADO.net. Is that important? No. ADO is an acronym. Back in the old days, and I don't even want to go over this with you because it was that long ago, but you didn't have a toolbox like you do now with all the good stuff in it where you've got your labels and your text boxes, etc. You had a very small toolbox with about 4 or 5 things in it. And if you wanted to add more, you had to go out to the internet and add them. Every time you added something, it was called an ActiveX data object. That's what that ADO stands for, just so you know. All right. What we're going to be more concerned with is once the software is installed, we have to communicate by using what's called SQL. SQL is an acronym that stands for Structured Query Language. Some people call it SQL, S-E-Q-U-E-L. Some people just call it SQL. I may do both, but I try to just say SQL. So as they say right here, you go in, and they're making this real simple here. You do not communicate directly with a database server. That's not what happens. In between here, you communicate with a server. That server communicates with a database server. The database server brings back stuff to the server. That server brings back information to you. But they're making it real simplistic here. All right. And you may have heard of this term already. You may not have heard of this term already. But it says the processing that's done on this side by the database management system, that's called back-end processing. All right. So that's done on the back end that you don't see. The stuff, the queries and stuff that you write that you get information back from, that's front-end processing, for lack of better words. All right. So they mention here the application software does the work the user wants to do. It can be purchased or developed. Good news for us rather, is it comes free in what we're using. All right. As it says here, the API that we're going to use is ADO.NET, which is built into the Microsoft .NET framework. All right. It says the processing we do again on our side is front end. All right. I don't know if you've ever heard the term, and I guess I'm asking, but there's two terms. Have you ever heard the term mean stack or MERN stack or MERN? No, yes?
No.
Okay.
No.
All right. I just want to quickly tell you that in the olden days, like maybe 5 years ago, people typically were front-end processors or they were back-end processors. If you were a front-end person, you were more a web developer. If you were a back-end person, you were more a programmer. All right? And the difference between, I don't know even know what they all stand for, but the difference between mean, M-E-A-N, and MERN, M-E-R-N, all right, is the A that's in mean stands for Angular, and the R that's in MERN stands for React. The N at the end stands for Node. Why am I even telling you that stuff? Because Node.js is a way to use JavaScript on both the client side and the server side. So today, when you've got a mean or a MERN developer, that's what they're doing. They're typically writing information that's used both on the front end and on the back end. All right. Now, one thing you may or may not have realized is literally everything that we've done thus far. All right. Any program that you've written, you can write the best program in the world. And this isn't it, but if we went back to our bank login program, I'm not saying that's the best program. Even the non-object oriented, it's not the best program. But I think you'd all agree that we can go and we can run that program. For example, we can run the non-object oriented bank login program. We can bring up our 5 customers. We can go and we can do all sorts of deposits, withdrawals, etc. And then when we get out of the program, all that information is lost. I'm not asking you that. I'm telling you that. If we want data to persist over time, there's 2 major ways that you can do it. You can save the information to files. All right. And you can have the files can be real simple text files. You probably have seen text files. Text files are files you can bring up with a text editor. So you can bring it up with, for example, Notepad or Notepad++. You can also save files as binary files. For instance, a Word file is a binary file. You can't bring a Word file up. You can't bring up a Word file in Notepad or Notepad++. It just looks like garbage. The file we're using right here, this PDF, is a binary file. All right. Now, files are fine. They're used for a lot of different things, but there's a lot of work to opening files, closing files, setting up file permissions, etc. So rather than doing file handling, most of the stuff is done via a database system. All right, so that's what we're going to be talking about right now. So let me go over this quick introduction that's in here. And then I want to go, and like I said, I'm going to bring up a screen, a blank screen in Notepad++, and then talk to you about a few things. All right. Back when I was your age, in fact, probably even younger than you, there was a show that was on TV. And that show was called American Bandstand. All right. It was on, I think, every Saturday, and they'd have an artist or a group that was real popular on, and they do one of their hit songs. The reason I'm telling you that is the guy who ran the program, his name was Dick Clark. You may or may not have heard of him. It's not that big a thing. Still on New Year's Eve, I think it's ABC, has Dick Clark's Rockin' New Year's Eve. All right. Even though Dick Clark died a few years ago. The reason I'm telling you that is Dick Clark was known as the father of rock and roll, which was big in the 60s and into the 70s. All right. And someone asked Dick Clark once, they said, "Do you consider yourself the father of rock and roll?" And he said, "No, but I'd like to think that when rock and roll was born, I helped in the birth." The reason I'm telling you that is that's who E.F. Codd is. E.F. Codd, that you see on the screen right here, is a mathematician. And he figured out a way to basically kind of combine math with computers to be able to save things in what's called a relational database. Now, is that a big thing? The big thing is this. Hopefully you can see what's in blue right now on the screen. And what's in blue is 1970. That's 50 years ago. All right. There are not many things that were used 50 years ago in the computer field that are still used today. Relational databases are an exception to that. Now, relational databases are not as popular as they used to be, but to my knowledge, they're still the most popular way of setting up databases. Relational databases are SQL, or structured query language databases. In fact, there are databases out there today. There's a popular type of database that's called NoSQL that doesn't use SQL. But I don't want you to think that you're learning, you're learning an old language, but it's not an obsolete language. It still is the de facto standard for database applications. So let's talk about how it's done, how it's used, etc. So it says here, the model for a relational database says the data is stored in one or more tables. All right, I'm going to break away from this for a second, and I'm going to come into here and into here. I know you can't see what I'm doing. You'll see it in a second. Let's see. All right, can you see my blank notepad screen right now with a number 1 over here? Y'all see that?
Yeah.
All right. I'm going to ask you a question. You're going to think it's a trick, but it's not. If I type in the word character, what do you think of? What's a character? And I don't mean somebody who acts like a character, but what's a character?
Just a letter or?
Letter, number, special thing. All right. To keep it simple, I'd say it's something on the keyboard. You may agree with that, you may not. There are other characters that you can use that aren't shown on the keyboard, but that's not important. You get the idea what a character is, okay? All right. So now I'm going to start giving you some definitions. So what's called a field, and it's also, excuse me, it's also called a column, is one or more related characters. So a field can be as small as one character. So if I've got a field called middle initial, it's going to be one character. If I've got a field that's called address, it might be as big as 100 characters, for example. All right. Now, if I create, let's just say that with all my students, I got everybody's middle initial. That probably wouldn't tell me very much, help me very much, etc. You know, as far as doing anything. So typically I want to put fields and I want to relate them together. As an example, I might have a first name field, a middle initial field, a last name field, an address field, a city field, a state field, a zip field, etc. All right, so right there I've got 6 or 7 fields. All right. So these fields, when I put them together, so if I had here Jeffrey P. Scott, 755 Parr Road, Wentzville, Missouri, 63367, that would be all information about me. All right, that would be a record about me. That record would hold 1, 2, 3, 4, 5, 6, 7 fields. Does all that make sense?
Yes.
Yeah.
All right. Again, probably wouldn't help that much, but then let's suppose that I wanted a record. I wanted the first name, middle initial, last name, address, city, state, and zip of every faculty member who works at Rankin. I don't care if they're St. Louis, Wentzville, or Perryville, but I want everybody's first name. I want everybody's middle initial, etc. All right. Then I'm putting all that into what's called a table. All right. Finally, that's fine. But if I decide that I want to not only include the instructors, so I want a table with all the instructors, but I also want a table with all the students. In fact, that's not even good enough. I want a table with all of the instructors. I want another table with all the administrators. I want another table with all the staff people, etc. That's when you get a database. Now, the only difference between a database and a file system, you can set this up as a file system. All right. But if it's set up as a database, you've got software that's able to interact with it, interrelate with it directly without having to do a lot of work as far as opening files, setting up modes for files. In other words, read only, write only, and closing files. You don't typically have to do that with databases because the software quite often will do that stuff for you. All right. So, any questions on what any of this stuff means?
No.
No.
All right. And again, you might say no, and you're making it really simplistic. Yes, I am. All right. And there it is. Because in the book, they talk about what a table is, then what a row is, then what a column is. You've now been introduced to them. All right. When you've got a row is also known as a record. When you've got a column, it's also known as a field. Now, when you're starting to do this stuff and you're coming in here and you're deciding, and I'm in my last 10 minutes, just so you know, but if you go in here and you're deciding Okay, so I've got everybody who works at Rankin Technical College. So let's say I've got a table with all of the faculty members. And let's say that I didn't put in middle initial. All right. I wanted just those 6 fields. All right. I don't know if you know this or not. You probably don't care. When I began work at Rankin almost 4 years ago, when we had our first meeting, we have these orientation meetings every semester. When I had my first orientation meeting, and I was down into this certain area at the St. Louis campus, I had a guy tap me on the back, and I said, "Yeah," and he goes, "Jeff Scott?" I said, "Yeah." He said, "Jeff Scott, nice to meet you," because they had a Jeffrey R. Scott working there. I'm Jeffrey P. Scott. I was constantly getting his mail. He'd get mine, etc. The reason I'm telling you that is there's nothing that's in here. There's nothing at all that's in here. Nothing that's in there that distinguishes any person from any other person. In other words, there's not a Jeff Scott Jr., but if there was, and he was a student here, let's say, or maybe even we were both faculty members, how would you be able to tell which one's me and which one's him if we lived at the same place? So what you typically do is you create what's called a primary key. And that is a unique record identifier. All right, I'm about to stop, but if you think about it, what do you think you would use as a unique record identifier? What's something that uniquely defines you?
Like for database stuff or just in general?
Just in general.
Social security number.
Perfect answer. All right. And we're going to come back to this in just a minute, but a primary key should be unintelligible. Tell me this, Keegan. If I'm a bad person and I get a hold of your social security number, can I possibly wreak havoc on your life?
Can you possibly what?
Can I possibly make your life a living hell?
Oh, yeah.
All right. A primary key should be unintelligible, meaning that if somebody finds it, if somebody finds out your primary key, it shouldn't matter. That's like for a customer number, it might be something like C123A57. So if somebody finds that out, they might be able to tell who the customer is, but they don't know their social security number because a primary key should be unintelligible. What unintelligible means is if somebody finds it out, there's nothing they can do with it. That's why it used to be primary keys were for databases with people in them, they were social security numbers. But after a while, they and for many people, they put them in what was called clear text. So they weren't even encoded. And if somebody got a hold of that database, now they'd have everybody's social security number. You don't want that. All right, so this is just about to be done because we're at 40 minutes, just about. So again, it is 9:21. Let's come back. Let's make it 9:35. All right, we're going to pick it up there. So feel free to drop off right now. Thanks.